Good morning, students. Today we will have a discussion there on very simple topic, that is binary addition and subtraction. So when we talk about the addition and subtraction in binary, before that let us review how we perform addition and subtraction there in the decimal form. So let us take one example here. How we can perform addition there in the decimal. So let us take the two numbers 87 and 78. So you can see here the addition will start from the rightmost digits first. So when 7 will be added with 8, then obviously we will have there in the result 5, because 7 plus 8, that will give us 15. So 5 will be used here, and this one will be the carry. So this carry will be forwarded there to the next position. So let us use carry here. So the total, again, earlier here in this position 2 digits are there, but now for this position we are having 3 digits. So in nutshell, 1 plus 8 plus 7, or 8 plus 7, 15, and 1 carry will be added. So we will have, the result is 165. So this will be the sum and this will be the carry. So what we mean to say here, in decimal addition, the concept of sum is there and the carry is there. Now in binary addition we will have the same sum and carry, but let's discuss one problem there in the binary, so that one could learn addition in the binary. Let me take the second example here in binary. Suppose there are two numbers 1101 1011. Let us say these numbers have to be added in binary. Now the things are very simpler. In decimal we know 0 plus 0 is 0. 0 plus 1 is 1. Or if I talk about 1 plus 0, then again it will be 1. So now next one is, what will be 1 plus 1? In decimal, obviously it will be 2. So you can see here when decimal 2 need to be represented in the binary, then it will be represented as 10. So we know that if we talk about the binary and the decimal equivalents, then 0 in decimal have the 0 in binary. Similarly, 1 in decimal will have 1 in binary. So 2 in decimal will have 1 0 in binary. 3 in decimal will have 1 1 there in the binary. Now let us add these two numbers. So you can see here 1 in binary need to be added with 1 in binary. So the calculation will start from this LSB part. Let us say this one. So you can see here 1 plus 1 in binary or in decimal, because you can see here using this 1 plus 1 in decimal is 2, and similarly in binary we can use 1 0 here, because you can see here the decimal of the binary of 1 1 is 1, and when 1 will be added with 1 we will have 2 in the decimal, but we need to use the binary notation, so obviously it will become 1 0. Now when 1 0 is need to be written here, it will be written like this will be the sum bit and this will be the carry bit. Clear? So now what we can do here, when 1 will be added with 1 we will use the sum bit as 0, like in this example you can see here, and this will be the carry bit. So 1 need to be added as the carry here on this position. Now you can see in this example when we were performing addition there at the LSB position, we were having 2 bits, and when we are having the carry, now the addition will be there in the form of 3 bits. Now again it is very simpler one, like the original bits are 0 and 1. So 0 and 1 will be added, obviously it will give 1. Now this 1 will be added with the carry. So again the same approach, 1 0 0 will be used here and 1 will be carried forwarded. Now for the next position 1 0, they will be added up, so we'll have 1 plus 0 1, and 1 will be added with the carry part. So again we will have 0 and 1 carry here. Now this is the carry basically there for the position, this one. Now we are left with 1 plus 1 plus 1, and even in decimal we know that, let us take this example here, 1 plus 1 in decimal is 3, and we know that 3 in binary is 1 1. So this will be the sum bit and this will be the carry bit. So now we are not having further more bits, so one can simply write 1 plus 1 plus 1 mean 1 1. So this is the final result we are having there. So it is a very simpler approach. By doing little bit practice, one can simply learn these numbers addition there in the binary form. So let me take another example here. Suppose the first number is 1001 and the second number is 101. Suppose these need to be added. Let us balance these one, because here we are having 4 bits and here we are having 3 bits. So by using 0 here, one can balance the numbers there. Now let us review the same thing here. The addition will start firstly from this point. So 1, 1, if we are talk about the decimal 1, obviously it will be 2. So this 2 in binary is written like 1 0. So this 0 will be the sum bit and this will be the carry bit. So that will be forwarded one. So you can see here 1 plus 1 0 with 1 carry. Now it is a 3-bit addition. You can see here 3-bit addition, then 0 plus 0, 0 plus 0, 0. Then 0 plus 0, 0 plus 1 carry bit will be added. So it will be 1. Now let us move to this position. So since there is no carry there from the previous position, so let us take it as a 0. So 0 plus 0, 0 plus 1, that will be 1. And since there is no carry again, let us take 0 here. So 0 plus 1 plus 0, that will be 1. So this is the result that we are having there. Now in digital electronics, basically we are having two circuits with which we can perform addition. The first one is half adder and the second one is full adder. When we talk about the half adder basically they are meant for, or they are used for addition of 2 bits, and the full adder, that is basically meant for or used for the addition of 3 bits. In both the circuits, the concept of sum and carry is there. Now let us use the basic behavior of these two circuits. So as I already told to you, we are having the concept of sum and carry. The half adder is meant for adding two single bit numbers. So there will be two inputs, let us say A and B, which will generate two outputs, sum and carry. Now the truth table. The truth table is of both the circuits. They are with respect to they will work according to the inputs. Or one can simply make the truth table of these half adder and full adder according to the problems that we have discussed in the form of previous examples there. So let us use the half adder firstly. So you can see here half adder mean two inputs. First one is A, the second one is B. We will have sum as output and the carry. So with two inputs we will have 4 combinations. With 2 inputs we'll have 4 combinations. So first time A0 0, A0 B1. Let us say third combination A1 B0, and the last combination is when both the inputs are 1 1. So you can see, let us calculate the sum. When 0 plus 0, as already told to you, 0 with carry 0. Then 0 plus 1, we are having sum as 1 and carry as 0. Now third row, 1 plus 0, the sum is 1, the carry is 0. Similarly, if we talk about the last row, 1 plus 1, the sum will be, according to the previous problem, the sum will be 0 with carry 1, because we know that 1 when will be added with 1, obviously in decimal it will be 2, but we are talking about the binary, so 2 in binary will be 1 0. So this bit will be the sum bit and this bit will be the carry bit. So that's why we are having carry as 1 and the sum bit as 0. So this is the truth table we are having there. One can simply learn, or from the previous discussed problem, one can write their own truth table. So it is very easy. Secondly, full adder. As I told to you that we are having 3 inputs and the 2 outputs. 3 inputs are, like in the previous problem, 3 inputs. So in full adder also we are having 2 outputs, sum and carry. So depending upon 3 inputs, we will have 8 combinations of inputs. Firstly 0 0 0, the second 0 0 1, then 0 1 0, and the last combination is 1 1 1. Now let us again discuss that how this 1 1 1 will be added here. Let us move there to this part. Let us calculate here also. 1 plus 1 plus 1. In decimal, obviously 1 plus 1 is 3, but we are talking about the binary addition, so 3 in decimal can be written as 1 1 in binary. So this bit will be the sum bit and this will be the carry bit. So you can see here, just because of this 1 1, we are having sum here 1 and the carry as 1. So with this approach, one can simply learn the truth table. One can simply write the truth table of both the circuits. Now second thing, or second part of our discussion is the subtraction. As we already know, the subtraction basically that is using the difference and borrow behavior, just like the adder, where just like the addition, where we are having the concept of sum and carry. Therefore in subtraction, the sum term is replaced with difference and the carry is going to be replaced with the term borrow. So let us take one example here for the subtraction. How the subtraction is basically done there in the decimal form. Let me take this example. 2-digit decimal subtraction like this. Suppose we need to subtract these. We need to have the subtraction between these two numbers. Now you can see here 4, the first two rightmost digits are 4 and 9. It means that 9 need to be subtracted there from 4. So obviously in this case we have to take the borrow. Now when we'll take the borrow value 1 there as a borrow, so this will become 14 and 14 minus 9, this will give us the difference, that is the 5. So let us write 5 here. Now you can see here one value borrow have been taken up to this position. Now for this position you can see here borrow need to be subtracted. So let me write borrow here. So you can see here 4 minus 3, it is 1. 4 minus 3, 1. 1 minus 1, because borrow need to be subtracted also, so it will be 0. In other words, suppose we can see if the same subtraction principle, because why we are using this one here in binary subtraction, we are going to use the same working style there. So we know that from childhood we people have learned like it will one borrow will be supplied here, it will become 5 there, then the value borrow we take it as 3, so 3 minus 3, again the result will be 0.5. So it hardly matters if we follow this approach or this approach, but why we are using this one here, because we are going to follow the same working, just a part of learning there for the binary subtraction. So it will make our task very easy. So let us take some example there in the binary form and learn the subtraction. Let us take first problem here. Let us say these are the two numbers that for which we have to perform the subtraction. So this is number A and this is number B. So B need to be subtracted there from A. Just like the addition, we know that 1 in decimal will be represented as 1 in binary. 2 in decimal will be represented as 1 0 in binary. 3 in decimal will be represented as 1 1 in binary. So let us do the subtraction. So the subtraction will start from this point, obviously from the LSB part. This is LSB and this position is basically known as MSB. LSB and MSB mean most significant bit, leftmost significant bit and the rightmost significant bit. So you can see here in decimal, when 1 need to be subtracted from 1, then it will result to 0. So in the binary, the same behavior is followed. 1 need to be subtracted, this 1 need to be subtracted from this one. So the result will be 0. So let us start with the next position. 0 minus 0, 0. Now this is the third position where we have to be little bit careful. 0 is there and the second bit is 1. So this 1 need to be subtracted there from 0. Now let us write, because in this case we know that borrow will be used. Borrow will be used. So borrow will be taken from this position. So this one is the larger number and this is the lower number. So we have to follow the borrow, just like this example there. Now when the borrow will be taken, this 0 will become 1 0 in binary, because just remember we are learning the binary subtraction. So 1 0 have to be used like this, and this 1 need to be subtracted from 1 0, and we know that 1 0 in binary mean 2 in the decimal. Similarly, 1 in binary mean 1 in the decimal. So in nutshell, if we talk about the decimal subtraction, it means that we are going to have the subtraction of 2 with 1. Mean 1 will be subtracted from 2. So obviously 2 minus 1, that will be 1. So we know that again 1 can be, it is the decimal 1, and we know that in binary again the 1 can be written as 1 in binary. So the difference will be, because we were talking about the difference and borrow. So in this case you can see here the difference will be 1 with borrow value 1. Clear? So you can see, now let us do the subtraction here. When borrow will be supplied here, it will become 1. Let us fill these two positions also. Now just like this method, borrow need to be subtracted. So similarly, borrow need to be subtracted from this position especially. Clear? So it is now a very simpler one, because 1 minus 1, it is 0. So this is the result that we are having there. Let me recall it so that the things become again more clear. One, 0, 1. If it has to be performed as a subtraction, we know that it is 2 in decimal, it is 1 in decimal. So 2 minus 1 is 1. And if we write the binary equivalent of 1, then it is 1. So difference value is D is the difference value, that is 1 with borrow, especially 1. So you can see when this subtraction will be carried out, so 1 minus 1 is 0, 0 minus 0 is 0. So here we have to take the borrow for this position. So 1, it will become 1 0. So 1 0, the difference value will be 1, but with 1 borrow value. So this borrow will be subtracted from this position. So 1 minus 1, it will become 0. So this is the final solution we are having there. Let us discuss one more problem there in the binary. Let us say the first number is 1 0 1 0. The second number is 0 1 1 0. So you can see here the subtraction will start from this position first. 0 minus 0 is 0. 1 minus 1 is 0. Now, when we move to this position, that is position number 3rd. Now, this is a position that will utilize the concept of borrow now. Now, when one borrow will be taken up, so this 0 will become 1 0. And second one is this need to be subtracted from this one. So this 0 will become 1 0. And already we have learned in the previous example, it is 2 in decimal, it is 1 in decimal. So we are having 1 in the decimal, and we know that this 1 in decimal can be written as 1 there in the binary. So the difference value is 1 and the borrow value is again 1. So you can see here, so this 1 0 for this particular position, it will be 1 as difference and 1 borrow need to be subtracted here. So let us discuss this position now. Just like this example, 4 minus 3 1, 1 minus borrow need to be subtracted, it becomes 0. The same thing we will apply here, 1 minus 1 0. So 0 and 1. So this 1 need to be subtracted from 0. Again, now we have to apply the same behavior. We have to take the borrow from this position. So when borrow will be taken up, it will become 1 0. The same principle. So it will become, we know that when this will be followed up, so it will become 1. And borrow need to be also subtracted from this position. So 1 minus 0, 1 minus 0, 1, and 1 minus 1, that is borrow need to be subtracted. So it will become basically the 0. That is basically the approach we apply or we use there in the subtraction part. So you can see here in digital electronics, basically we are having two circuits. First one is half subtractor and the second one is full subtractor. So half subtractor are basically used for performing subtraction using 2 bits, and full subtractor they are used with 3-bit subtraction. So in this example you can see here at the LSB, when you can see in this example which we have discussed here, for these two positions we are having 2 bits are there, so half subtractor will be used. Similarly here again half subtractor will be used, but especially for this point, this position where we are having the concept of borrow, especially when we are doing the subtraction there in the form of 3 bits, we are having the full subtractor basically, and when we are doing the subtraction with 2 bits, in 2 bits we are having the half subtractor. So let us review what half subtractors are meant for. They uses two outputs, because both the circuitry is just like adders using two outputs. So here subtractor will produce difference as an output, borrow as an output, and two inputs for half subtractor, let us say A and B. Similarly for full subtractor we are having again the two outputs, difference and borrow, but here the difference is full subtractor contain 3 inputs and 2 outputs, so it is going to work there with the 3 inputs. Now what is the truth table basically for an half subtractor or full subtractor basically? Let us draw this one also. It is very easy to draw. One can simply learn or one can simply write the truth table, because we have already learned the problems there. So half subtractor, it required 2 inputs. Let me draw it here. The first value is A, the second value is B. The first input is A, second one is B. So we are having the difference, we are having the borrow. So depending upon, because 2 inputs, so we'll have the 4 combinations. First combination is 0 0, 0 1, 1 0 and 1 1. So you can see here 0 minus 0, difference is 0. The borrow required is 0. 0 minus 1, you can see here. Now from the previous problems you can see here we have to basically use the borrow, and the difference will be 1. Similarly, when 1 minus 0 is there, so 0 need to be subtracted from this value 1, so the difference again will be 1 with borrow value 0, and if 1 have to be subtracted from 1, the difference will be 0, with borrow value 0. So this is the case that one have to take care. So I hope in the same way one can draw the, or one can use the working of full subtractor, which is basically there with the 3 inputs and just like the half subtractor with 2 outputs. So the outputs are again, let us say, difference and the borrow value. So we'll have with 3 inputs 8 combinations. The first time 0 0 0. So in these examples, basically you can see here we have utilized all those scenarios. We have performed the subtraction with the 3 bits. We have performed the subtraction with the 2 bits. Like if I have to talk about this or any entry here, so it is, suppose let me take the example of this row 0 0 0 0 minus 0 minus, obviously then the difference value will be 0. So that's why we are having. So do we require borrow here? No. So it will be 0. Okay. Next one is 0 0 1. So we know that 0 minus 0 is 0. Now we have to subtract this 1 from 0, the result of these two basically. So here in this example 0 1, this is the example we are having there. So we know that we have to take a borrow, that is 1, and the difference value will be 1. Similarly, if we talk about this input, it is 0 1 0. So again the sum borrow will be 0, the difference will be 1. So I hope with this way one can learn or one can make the truth table of full subtractor also. So it's all about the binary addition and subtraction, as well as their implementation in the form of digital circuits. Thank you.